Hey, welcome back to our series on LeetCode Daily Questions. Today we're tackling August 28th question 1905, count sub-islands. All right, so it's a medium question, and we're going to go ahead and go through it. So you are given two M by N binary matrices, grid 1 and grid 2. So this will be a matrix or an array of arrays, and they will both be the same size. So we have grid 1 and grid 2 of ones or zeros. Zeros representing water and ones representing land. An island is a group of ones connected directionally, horizontal and vertical, so up or left or right or down. Any cells outside of the grid are considered water cells. Okay. So beyond, I guess, like -0, or above the length or the length of the array, those are considered water. All right, so return the number of islands. An island in grid 2 is considered a sub-island if there's an island in grid 1 that contains all the cells that make up this island in grid 2. So let's see, over here we have grid 1, and over here we have grid 2. In red we have the sub-islands, so this is what we're looking at here. We have this one, 0, 0, which appears over here in grid 1, 0, 1, which appears in grid 1 as well, 0, 2, which appears in grid 1, 1, 2, which appears in grid 1, 1, 3, and 1, 4, which also appear in grid 1. So this makes one island here. So this is one single island. And then also down here we have this, which corresponds to this one here, and this is an island itself, and then also this one here, which is also an island down here. So we're going to jump all the way over here. I pre-created this just to save some time. So we'll use our gold. So basically what we saw is that this here is our island. This here is an island. And then this one here is our island. Now, these correspond with these over here, so we don't need that one there at 1, 1. Corresponds with this island and this island. So we have 3 sub-islands. So over here, even though we have this one and we have this one, we'll use red for this. This sub-island here is not a sub-island because over here we don't have a match over here and over here. Same thing with this one. Over there, no match, and then, yeah. So basically what we're going to do is we need to find every island over here, make sure that each piece of the land exists on grid 1, and if we make sure they all exist and we have completed the island, then we increase a counter by 1. So let's go ahead and come up here. So we're going to have M times N. Let's not do that. Let's just go with some real words. So we have a M by N, but I'm going to be calling it row and column, or we'll call it rows and calls. Feel free to always do this in the interview. Makes it easier for you to follow along, not confuse yourself, and also makes it easier for the interviewer to follow along. And then what we want to do is find the islands in grid 2. And then what we want to do when we find one is make sure they exist in grid 1. So the approach I'm going to be using today is a depth first search. So we're going to be looking up and down and left and right, and we're going to make sure that we hit all of the pieces of the island and make sure they exist in grid 1. Alright, we're coming over here. I already showed you all the YouTube videos I was watching. So we're going to come over here and go ahead and type it up. So first what we want to get is the limits. So instead of using m and n, we're going to be using rows, which will be the value of grid1.length. And we're also going to be using this one here, columns, which will be equal to grid2.length. All right. And then what we want to do is we're going to come up here. We're going to have a DFS function that will be passing in a row and a column. This will be the DFS to find the island. We'll come back and fill that in a bit. And what we want to do is also have our count. So let our count is equal to 0. And then we're going to do a for loop. And this for loop will go through every row and column, every item inside of it. So for we'll call it row equals 0. Row is less than our rows right here. And we're going to increase our row. So we're going to go element by element through the entire matrix until we find an island in grid 2. And then we also need to go through our column. So for let column equals 0, column is less than cols, and we're going to be increasing our columns. So we're going to go 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then we'll break out. Then we'll come back here, we'll increase row, we'll go 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, etc. Making sure that we hit every element in our matrix. So we're going to do this, and then we're going to say if our grid 2 at our row column, and we're looking for an island, so we'll say if it is equal to 1, which represents land, what we want to do is say that our count will be plus equal to our DFS. So DFS for this one, we're going to be returning either true or false. And in JavaScript, true is equal to 1, false is equal to 0. So it would be the same thing as just incrementing row column, incrementing our count. So another way of doing this would be let is sub equal DFS at row column, and then we could say if is sub equals true, then we can say count plus plus. That's one way of doing it. The other way of doing it is the way I'm doing it right now, which is just increasing it by 1. And then at the end, we want to make sure that we return our count. So now what we got to do is go back into our DFS. So we're going to come back up here, and the first thing we want to do is make sure that we account for breaking outside of the bounds, and also in case we hit a 0, which would mean that would also be the edge of the island. So we're going to do a quick check for that. So we're going to say if our row is less than 0, or if our column is less than 0, or if our row is greater than or equal to rows. So that would be the breaking out over here. Or if our column is greater than or equal to columns, which will be breaking out on this side. Or if our grid 2 at row and column is equal to 0. So that would be, for example, hitting here. What we want to do is return true. So that would mean that we have reached the edge of our island. All right. Next up, we're going to come down here. And there are two ways of keeping track of our visited. One is to have a set called visited, where we add the row and column to it. Another way that you can do it is just by changing the value. So grid 2 at row column, we're going to set that equal to 0. If your interviewer does not want you to change the grid at all, another way of doing it would be to put a set outside, and then you'll be able to add this element to the set And over here, instead of saying we could add another one that said if our visited set has the row and column, then we'd also return true. All right, so we have grid 2, row column of 0, and then we'll come down here, and we want to say let our is a sub island equal to true. And then what we want to do is make sure that this island appears over here. So if our grid 1, this is where we're doing our check at row and column, is equal to 0, what we want to do is we want to change line 17 to false. So we say is sub island equals false. So this is the check. Another way of doing this would be to, I guess, get rid of this and this. You can say if our grid 1 at row and column is equal to 1, then it will be true. If it is not, if it is a 0, then this will be set to false. So that is another way of doing it. I'm going to do it this way. One line, a bit cleaner, maybe a bit harder to read, but there's pros and cons to everything. And then next we want to check our up, our down, our left, and our right. So over here we'll say const, and we're going to call it up. We're going to call it the DFS again. And this time we are going to be checking up. So we have row and column. When we go up from 1 to 0, that is actually row minus 1. When I interviewed people, a lot of people get very confused by going up. They'll say it is +1, but it is -1. So make sure you use the pictures over here. Then we'll go down is equal to DFS, and then we'll say row +1. I know down is adding, but that's how it works in the matrix. And then we'll have our column, and then we'll have our left. So that would be moving from, let's say, this 4 to this 3. So that'd be DFS of row, and then we'll say column -1. And then we also have our right, and that will be DFS of our row and column +1. So we'll go through that. So we get all of these values. And then at the end, what we want to do is return. And what do we want to return? We want to make sure that all of these are true. If one of them is false, then we need to return false. So we'll say, we'll return is sub island, and up, and down, and left, and right. And if that is true, that will return a true, which would be equal to a 1. Is equal to 1, false is equal to 0, just binary. So we'll be either increasing it by 1 or increasing it by 0 if it is not a sub-island, which means, for example, this one here does not appear over here. That would return a false, so this would be count plus equal 0. And then, yeah, this is more or less how you do it. Let's go ahead and run a test. Hopefully it works. It does not work. We have a mistake. Where did we mess up at? Okay, we're increasing it by 1 too many. Maybe, let's see. Oh, there we go. Sorry about that. I should not have deleted this. So we'll do const. We'll call it const. This is sub island. Sorry about that. And let's run it. And we do pass. So make sure that when you declare a variable and then you change that variable, that you need to keep the declaration statement of constant or let, etc. I'll go ahead and submit it. What do we get? We have a wrong answer. Okay, what is wrong? We have an output of 4. Let's go through this. Something is wrong. All right, let's go through our code again. So we have our rows is equal to 1.length. Oh, here we go. It's not grid 2, it's grid 1, and we're taking the, all right, that should fix it. So grid 1, and we're taking the length of the columns rather than the length of grid 2. That very stupid mistake, but we were able to catch it. I'll always go back through your code. Let's submit it one more time. And we do pass. All right, we beat 70% of people. So now when it comes to time and space complexity, time, pretty straightforward. You have to hit every single element. So one way of talking about it would be rows times columns, or you could just say O of n, because you can just say it's the number of elements in the array, or the number of elements in the matrix. So it'll be O of n. And then space complexity, that would be the, I guess, the call stack of our DFS. So worst case scenario, the entirety of grid 2 is an island. So that would also be O of n. Yeah, pretty straightforward. If you have any questions, let me know. And stick around for another video later this week. Thank you guys.